All right, we are going to end these videos talking about the plate tectonic setting, right? Where on Earth do we typically find these types of igneous rocks? Well, the place that produces the most igneous rocks is at mid-ocean ridges, right? Makes sense. This is where most of the volcanoes on Earth are. It's where lava is almost constantly extruding from beneath the lithosphere. It's where new oceanic crust is being created. So it makes sense there's a lot of igneous rocks there. So mid-ocean ridges are the most productive. More than 10 cubic kilometers of mid-ocean ridge basalt is erupted worldwide each year along the mid-ocean ridge system. And all of this magma, all this lava solidifies into igneous rocks. Now, despite extensive sampling with dredges and drill holes, we actually don't know a ton about the deeper rocks because most of them are subducted into the mantle at convergent plate boundaries. All right, so a lot of that igneous rock that has been created over the history of Earth was eventually consumed back into the mantle. However, on rare occasions, that sequence of igneous rocks that is hard to get to on the ocean floor is actually preserved, and we get to see it as what we call an ophiolite sequence or an ophiolite suite. And from those, we're able to determine, right, what a cross-section of a mid-ocean ridge might look like. So at the very surface of the mid-ocean ridge on the ocean floor, you're going to get more likely to get pillow lavas there. Remember, pillow lavas are formed where the lava actually comes in contact with the cold ocean. Right? And then beneath those pillow lavas is where you're going to find those sheeted dikes that form as a dike wells up to the middle of the mid-ocean ridge and then cools and is split apart, and that happens over and over and over again. And then below those sheeted dikes, you're going to get a series of more and more mafic rocks. All right, finally, igneous rocks don't just form at divergent plate boundaries, they also form near convergent plate boundaries. This isn't as often or numerous, but right, igneous rocks are still created here, and this is through flux melting, right? So as we know, as an oceanic tectonic plate is subducted down at a convergent plate margin, at a subduction zone, the hydrous minerals in that oceanic crust, the minerals that have a lot of water incorporated into their crystalline structure, are going to go down to great depths. Metamorphism is going to cause those minerals to release that water, and that water is going to rise up into the asthenosphere of the overlying plate. That water is volatile, meaning it's going to lower the melting temperature of the mantle rocks around it, creating, right, rising magma, volcanoes, and all of, not all, but many of the igneous deposits we've talked about up until this point.